మీరు ఎందుకు absent? మీరందరూ ఎందుకు రాలేదు? స్లైడ్ షో పెట్టండి. వదిలేండి, మళ్ళీ అది కింద పడిపోతుంది కష్టం. Okay, అదే ఆటోమేటిక్. So yesterday we have discussed about unit 2, unit 3. What is about unit 3? In unit 3 we have started how to design a decision tree, how to implement a decision tree. Is it right? So what are the different parameters we need to consider while we are doing decision trees? What are the different parameters based on what we are going to find the proximity? On two factors we are going to classify and find the proximity. What are the two factors then? One is distance measure, another one is distance, another one is similarity. Is it right? Proximity or similarity. Based on these two features we are going to write the decision tree. Okay, in decision trees we are going to use one algorithm. What is that algorithm? What is that algorithm? What is KIET algorithm? Combination of two algorithms. What are those two algorithms? What are those two algorithms? Classification. Classification and regression. What is regression? What we are going to do in regression? What we are going to do in regression? Predict chestar. What we are going to do in classification? What we are going to do the classification? Classification lo em chestam? Category spam kaadu, em chestamandi classification lo manam. What we will do in classification? So in decision trees we are going to draw the decision tree based on the given data set, okay, by considering two factors. One is distance measure as well as the similarity. Based on these two factors we are going to draw the decision tree. Okay, how many root nodes will be there? How many root nodes will be there? How many root nodes will be there in a decision tree? 1, 2, 1. How many parent nodes will be there? Number of how many child nodes can be? Okay. What is the is root node is a parent node? Is root node is a parent node? Look at the board. Is root node is a parent node? Is parent node is a root node? There is no condition that every parent node should be a root node. but the root node can be every time a parent node. Our child nodes can be leaf nodes. All child nodes can be leaf nodes. All leaf nodes can be child nodes. All leaf nodes can be child nodes. Yes. All child nodes are leaf nodes? No. All child nodes can't be a leaf nodes. Okay. Now we have finished this. We have finished this. అయిపోయిందా నిన్న క్లాస్లో ఇది? So here in decision tree, in decision trees, we are going to use the KIET algorithm, classification as well as regression. Yesterday we have seen one example regarding classification and regression prediction. Is it right? What is that example? Which example we have shown? Which game it is? Which game it is? Playing of tennis based on the weather predictions. Okay. And one more thing is only based on yes or no condition. Next slide. We have seen this example. This example is given by a person who wants to travel in a vehicle. He wants to decide about a vehicle to travel with some number of persons. With some number of persons. Why we are taking this an example is previous slide into. Here we are telling that the splitting is done based on Boolean functions. Okay, what is Boolean function? True or false, yes or no. So based on only that, the splitting can be done. So here he is asking whether the chosen vehicle is alive or not. Why we are telling vehicle as alive or not is before the invention of the vehicles, we all know we used to use the animals for our traveling. Okay, he is asking whether the vehicle decided is alive or not. మనం ఏదైతే వెహికల్ కావాలనుకున్నామో అది అలైవా కాదా అంటే బ్రతికుందా లేకపోతే మామూలు మెషినా ఎందుకు అని అంటే వెహికల్స్ కన్నా ముందు we used to use bullock carts, okay, donkeys, camels, etc. for traveling purpose. So he is telling that no, the vehicle which is chosen is not alive, whether it may be car, aeroplane, etc., etc. It is not alive, it is a machine. Is it right? Is it right? Don't sleep in the first hour itself. Is it right? What right? What right? Yes ma'am అన్నావు కదా ఏంటి దేనికి yes ma'am అన్నావు? Here he is asking whether the vehicle is alive or not. So we are telling that no, because the chosen vehicle is not alive, it is a machine. So his next question is, does it fly? Why is asking does it fly? Because if the vehicle is aeroplane, suppose maybe if the vehicle is aeroplane, he is asking whether it is going to fly or not. Yes or no condition. If it is yes, we are going to choose the aeroplane. If it is no, he is asking whether the chosen vehicle can carry more than 10 people or not. Is it necessary? Is it necessary to ask the question? Yes, because if he chooses a two-wheeler vehicle, does it carry more than one people other than the driver? Does motorcycle will carry more than one people? ఇప్పుడు బైక్ తీసుకున్నారు అనుకోండి అది ఒక్కరికన్నా ఎక్కువ హ్యాండిల్ చేయగలుగుతుందా? Only 2 persons can travel in a bike. Is it right? Is it right? So he is asking that no. If it is no, the vehicle is car. If he wants to carry more than 10 people, the vehicle is bus. So this is a decision tree made based on the yes or no condition. Okay, next. Next. So here can contain yes or no condition as well as the numeric data. Yesterday we have seen an example for the numeric data. Yes or no? What is that example? What is that example? Next. This is a decision tree. This is a tree. In a tree, root node is a parent node. All parent nodes can't be a root node. All child nodes are not leaf nodes. All leaf nodes are child nodes. ఓకే అర్థమైందా లాస్ట్ నోట్స్ ఏవైతే ఉంటాయో అవి మాత్రమే లీఫ్ నోట్స్ ఓన్లీ లాస్ట్ నోట్స్ ద రెస్ట్ ఆఫ్ ఆల్ ఆర్ చైల్డ్ నోట్స్ ఓకే ఇఫ్ సపోజ్ దిస్ ఈజ్ ఏ సబ్ ట్రీ ఈజ్ ఏ పార్ట్ ఆఫ్ ఎ ట్రీ if this is a subtree, this subtree can internally contains another subtree. Okay, next. So this is the example we have dealt yesterday based on the classification and regression. Here, these data is the classified data. Okay, ee data edaithe undo adi classified aina data. Ee data edaithe undo adi predicted data. Prediction ante enti? What is prediction? What is prediction? Yes or no? We should judge whether that condition is correct or not. In this example, he itself has given the classified data as well as the predicted data. For each row, he is giving one prediction. Okay, whether to play tennis or not. Okay, next. This is a program we have seen yesterday. Ever చూడలేదు program నిన్న క్లాస్ కి ఎవరు రాలేదండి క్లాస్ కి నెక్స్ట్ does decision trees mimic same as human yes why how you can tell it is predicting based on our given data only it is automatically predicting yes or no condition it is not lagging in giving the decision okay decision tree eppudaina sare meer tree chusinappudu you can easily identify easy ga meer gurtinchavochu enti edi correct condition edi wrong condition is it right next by using the decision tree can you easily understand the data can you easily understand the data by using the decision tree yes or no so that is so here the decision tree can be easily understandable okay with little data trained data with little data set but whenever you do small minimum changes for the decision tree it is very difficult to identify that small changes if suppose I am drawing the decision tree of depth 2 yesterday we have seen an example of program depth 2 means I need for my decision tree only 2 children suppose I am a root node నాకు only 2 children ఏ కావాలి అనుకుంటే if I do any changes I can redraw the decision tree is it right but ఒకవేళ డెసిషన్ ట్రీ చాలా పెద్దగా ఉంటే మీరు ఏదైనా చిన్న చేంజ్ చేస్తే ఇట్ ఈస్ వెరీ డిఫికల్ట్ టు రీడ్రా ద డెసిషన్ ట్రీ ఓకే నెక్స్ట్ సో దీస్ ఆర్ ద డిఫరెంట్ టర్మినాలజీస్ నిన్న రాసారా డిఫరెంట్ టర్మినాలజీస్ నిన్న రాసారా రాయలేదా యాక్టివ్గా ఉండండి రాశారు కదా నెక్స్ట్ okay so in decision trees what are the 2 algorithms we use classification and regression trees decision trees are divided based on the nature of its performance based on the classification tree based on the prediction, regression trees. These are the two examples for regression trees and classification trees. So here previously I told in the slide it is represented as classification can be done not only based on categorical but based on the numerical data also. Is it right? Ikkada meer cheppandi. See, in the given example, vaadu only images ichchadu, male and female images. Now based on the features, వాళ్ళ పోలికలను బట్టి వాళ్ళ రూపురేఖలను బట్టి మనం డెసిషన్ ట్రీ డ్రా చేయాలి. ఓకే, ఇక్కడ though there are female images, we can easily identify who is small and who is big. Is it right? ఎస్సా కాదా? మాటలు సరిగ్గా sit straight all of you. Based on the features, we tell that classification can be done based on distance, based on similarity. Kada? Two types. Ikkada vaalichina images lo based on features we are going to divide. Here for our decision tree to be divided, we should give some question to it. Is it right? What is the numerical data we are assuming here is age. Here in the example they have given the features and also they are giving take input as either age, gender or occupation. Okay, take input as age, gender, occupation. Do we know by seeing them what occupation they do? Do we know? So example, by seeing me what occupation I do, what you can do, what occupation I am doing now? Teaching. Other than teaching, I will do another occupation also. You know that? No. But by seeing me, you can judge that I am a female. Is it right? By seeing the features. By seeing me, you can judge my possibility of my age, nearest of my age. So same thing I have taken here. I have taken the input as age as well as the gender. Okay, here ఇక్కడ చిన్న మిస్టేక్ అయింది. నిన్న మీరు ఐడెంటిఫై చేశారు కదా మిస్క్లాసిఫికేషన్. సో హియర్ I have taken the age as less than 15 because I have to divide the class. I have to do the classification based on the features. For age less than 15, I am getting two, left tree, right tree. Okay, right tree, left tree I am getting. So here less than 15. For age less than 15, this is not no, this is S. Okay, for age less than 15, these two images will come under that. Is it right? By seeing the features, we can tell which images come under age less than 15. Okay, age greater than 15, here we will get these images. Okay, so here among these subtree, again I am telling which gender is it male or female. Okay, if it is male, is male. If yes, this image can be divided. If no, this image. Okay, this is the decision tree which we have been implemented based on the given data. Vaadichina data lo taking the features as the similarity, we have divided this decision tree. Okay, now can I divide this subtree also into one more depth? ఈ సబ్ట్రీ ఉంది కదా, దీన్ని కూడా ఇంకో చిన్న చైల్డ్ నోట్స్ లాగా చేయొచ్చా? నేను చేయొచ్చా? వాట్ ఈస్ ద ఇన్పుట్ ఐ హ్యావ్ టు గివ్ హియర్? Gender. Is it right? We are taking input here as age, gender as well as the occupation. As we can't identify which occupation he is doing, he or she is doing, we are taking two as input as well as the gender. So here we can give the gender as an input and also further we can divide male or female. Okay, the decision tree number of children to be generated completely depends upon our decision. How many depth nodes we need, that many number of depth nodes we can do. Okay, next. different impurity measures. Yesterday we discussed about different impurity measures. Now tell me why we need the after doing the classification of the decision tree, is it necessary to judge whether the classification is correct or not? Is it necessary? See open the previous slide. This is a decision tree I have drawn. Okay. Is it necessary to check whether it is correct or not? Yes. Is there any mistake here? Is there any mistake here? Yes or no? What is that mistake? The prediction which I have made is wrong. Is it right? The prediction which I have made is wrong. Here, age less than 15. Less than 15 means if S, it should here it should be S, here should be no. Okay? For that sake, whether the classification is done, whether the decision tree is made for small data set or big data set, it is necessary to check whether the classification done is correct or not. Okay. In unit 1, we have discussed a word of our testing. Whenever we train a model for machine learning, we need to check the accuracy. Do you remember? Do you remember? For every data set, whether it is a small data set or big data set, we need to check the accuracy. Okay? Why we need to check the accuracy? Why we need to check the accuracy? Whether correct data, first one is whether correct data set is trained or not, whether the trained data set can be applicable for further sample testing or not. Okay? If at all that accuracy is less, again we are going to change the model we are using, algorithm we are using, the data set we are going to recorrect that data set. Okay, similarly here also we need to check the misclassification done on decision trees. Okay, in the previous example, mundu example lo mistake ayindi kada, adi chinna data set kabatti, chinna tree kabatti, we have easily identified that mistake. ఆ ఇమేజ్ ని చూడంగానే ప్రెడిక్షన్ ఎస్ ఆర్ నో కండిషన్ ఏదైతే ఉందో అది రాంగ్ లో ఇంప్లిమెంట్ అయిందని చూడంగానే గుర్తుపట్టాం. బట్ ఇఫ్ సపోజ్ ద డాటా సెట్ ఈస్ మోర్, ఇఫ్ ద ట్రైన్డ్ డాటా సెట్, ఇఫ్ ద డెసిషన్ ట్రీ విచ్ ఈస్ మేడ్ ఈస్ మోర్, if some mistake is happened, what is the situation? So for that sake, the identification of misclassification, we are using 3 formulas. What is the first one? Gini index. Second one, entropy. Third one, information gate. Among these 3 formulas, which is more easy? Which is more easy? Gini impurity. Gini impurity. It is very easy to implement. It is very easy to implement because here we are going to find the pair, whatever the node we want to check whether that classification is correct or not. We are going to take that probability value only. If at all, if it is having more subtrees, we are going to do the summation of that probability of misclassification. This is an example. These are the other 2 impurity measures. The first one is we are going to calculate the logarithmic value of the obtained probability. Whereas coming to the information gain, we are going to find out the difference between the entropy value, this entropy value of the parent node as well as the subset of that parent node, as well as a subset. So that's why if at all any small changes is there for the decision tree, it is very difficult to find out the misclassification by using these formulas, these 2 formulas. That's why we prefer more for Gini impurity measure, Gini index, because if at all small changes are there, it is difficult to find out the impurity measure by using these 2 formulas. That's why we tell that Gini impurity is the best for finding the impurity measure, that is misclassification of the decision tree. So this is the graph. This graph is very important. This graph is very important. If you don't write the example also, if you write this graph, if you represent this graph in your exam, you will get the full marks. Because here in this graph, we are telling that it is easy to use Gini impurity index because it marks up to 0.5. Okay, than entropy values. Why we tell Gini is more flexible to use is for entropy and other information gain, we must and should calculate the logarithmic values. Madam, information gain lo logarithm value and represent cheyaledu kada madam, we logarithm antunnarante. Information gain lo we have to write the entropy value only. We are writing the difference of the entropy of parent node as well as the subnodes. Entropy value antene logarithmic values. That's why we tell that better to use Gini impurity measure. Please look out this PPT. ఒకసారి చదవండి ఇది. ఇప్పుడు ఇది యూట్యూబ్ మళ్ళీ మన ఫస్ట్ నుంచి చెప్పింది స్టార్టింగ్ రికార్డెడ్ ఉంటుందా, ఇప్పుడు స్టార్ట్ అవుతుందా?
ప్రీవియస్ 4 ఉంటే మనం మార్నింగ్ ఆఫ్ రెండు ఇవాళ
ఒక్క నిమిషం. Now look at the board. From here we will again start from for today's class. Now we will discuss about the regression based on decision trees. Regression based on decision trees. Why we are in detail we are classifying is in the previous example where we have classified the data based on the taking input as age and gender. We are telling that నేను ఏం చెప్పాను ఇక్కడ వచ్చిన ఇట్ సైడ్ వచ్చిన సబ్ ట్రీ కి we can further divide. ఇంకా కావాలంటే ఇంకా నేను చైల్డ్ నోట్స్ ఇవ్వచ్చు. Okay, so here based on the prediction conditions, now we are going to draw the decision tree. Okay, how to draw the decision tree? Tell me an example whether we can predict the price of a house. Down, stand up. Is the price of a house changes from Hyderabad to Kakinada compared to Hyderabad and Kakinada? ఇప్పుడు మనం ఒక అపార్ట్మెంట్ తీసుకుంటున్నామండి, ఒక అపార్ట్మెంట్. ఓకే, యు నో అబౌట్ అపార్ట్మెంట్? యు నో అపార్ట్మెంట్? డబుల్ వాయిస్ ఇస్తుందా? మీకోసం ఆఫ్ చేస్తా. అపార్ట్మెంట్ గురించి తెలుసా మీకు? కాకినాడలో అపార్ట్మెంట్ రేట్, హైదరాబాద్ లో అపార్ట్మెంట్ రేట్ సేమ్ ఉంటాయా? చేంజెస్ ఉంటాయి కదా. ఇక్కడ ఏరియాలో ఉన్న అపార్ట్మెంట్ రేట్, కాకినాడ స్టేషన్ దగ్గర ఉన్న అపార్ట్మెంట్ రేట్ చేంజెస్ ఉంటాయా? అది నాకు తెలీదు, అందుకే మిమ్మల్ని అడిగాను. సో హియర్ we will take an example of an price give a price given for buying a house. Okay, the value of the house, the price of the house can be predicted based on different attributes. Is it right or not? Not only the location, the dimensions of the house, the number of splits made in that required dimension of the house also. ఓకే, ఇప్పుడు 100 స్క్వేర్ యార్డ్స్ ఉందనుకోండి, ఇది 100 స్క్వేర్ యార్డ్స్ ఉంటుందా? సపోజ్ వీ థింక్, బికాస్ వీఆర్ డూయింగ్ ద ప్రెడిక్షన్, సో దిస్ ఈస్ 100 స్క్వేర్ యార్డ్స్ ఆఫ్ ప్లేస్. ఓకే, ఇఫ్ ఈజ్ ఓన్లీ వన్ సింగిల్ రూమ్, ద ప్రైస్ విల్ చేంజ్. ఓకే, ఇఫ్ దేర్ ఆర్ 4 splits in this room, the price is more. Why? The requirements needed for that 4 rooms will also be more, whereas compared to the requirements needed for single room of the same 400 square yard space. Okay, so here we are giving an example is predicting the house prices of the house based on different features, that may be a size, location, number of splits. Okay, first one okate. Okay, this is an example we have discussed for the last half an hour. Is it right? So here we are taking an example of a graph. There they have given different data points. Is it right? Here they have given different data points. Stand up. Last. Mere luncheon. This is a graph. Okay, different data points ఉన్నాయి ఇందులో. ఓకే, ఇందులో ఏ కలర్ డాటా పాయింట్స్ ఉన్నాయి? ఏ కలర్ ఉన్నాయి ఇవి? రెడ్, గ్రీన్. సో your task is to divide these data points. Okay, now we have to do the splitting, classification only by seeing that data points. Okay, how many classification we can do? In a user and 4 antunara. So they didn't given that to classify only into 2 parts, because this is in a this data points is in a open area, open plot graph, where not only red points on each side, green points on each side and lame level. There are different locations of the both types of data points. So he also didn't given that to do only 2 splits, 3 classification, 4 classification or 5 classification. He is telling that how many type, in how many ways you can do the classification, you can do. Okay, now classify that data. మీరే మామూలుగా పాయింట్స్ వేసుకొని గ్రాఫ్ వేసుకొని క్లాసిఫై చేయండి. ఏం వేస్తాం మేడం అంటే అట్లనే వేయాలి, అట్లా లేదు. See, don't use the shapes of triangle, plus, minus. Just keep the dots of your own, and how you can classify that. చేయండి. అదేంటి మేడం మీరు చెప్పడానికి వచ్చి మాతో చేయిస్తున్నారటవా? నాకు రాదబ్బా, అందుకే మీతో చేయిస్తున్నాను. ఏంటది? Next slide button. So here in the second graph, in the second split, we have done only one division. ఒకసారి చూడండి. In the second graph, ఈ second graph లో మనం ఏం చేసామంటే we have make one horizontal line and we are doing two types of splits, two classifications, okay, between this line, between this data and this data. Can we further do the classification? Inka classify cheyacha ee graph ni? Inka classify cheyacha? Second graph. See here, the data which is above this mark, again I have done one classification, split two. Okay, further can I do? Inka cheyocha danni? Inka cheyocha? Next. So here I have done another classification, split 3. Okay, after doing the split 3 here, one more split I can do, split 4. Okay, in this way the number of classification on the given data set depends upon us. So how many we can do? We can do the data set. Oxa system even. ఏం రాస్తున్నారు మీరు? Look at this program. Students who have missed yesterday's class, look at this program. Here I am telling that the maximum number of children I need is 5. That's why I have given max depth equal to 5. The number of splits I need is 5. Previous exam lo manam example lo 4 split chesam kada. Ee program lo edaithe data set nenu teeskunnano, I need 5 splits. So I have given their number 5. Now I don't want 5 splits. I need only 3 splits. Means the number of levels of children, I need only 3. Now I will change the number of splits to 3. So the number of splits will be changed to 3. He is not giving the condition that how many splits you need. Okay. If the data set is more, if you find that misclassification can happen in the decision tree, at some point of time, you can go for the number, increase the number of levels. Okay. Now keep heading bias variance. What is bias variance? What is bias variance? What is bias variance? Difference. What difference? Bias difference. బయాస్ డిఫరెన్సా మీకు గుర్తుందా ఇంతకుముందు క్లాసిఫికేషన్ టాపిక్ చెప్పినప్పుడు మనం ఇంప్యూరిటీ మెజర్ ఫైండ్ అవుట్ చేయాలి కదా వెదర్ మిస్ క్లాసిఫికేషన్ ఇస్ డన్ ఆర్ నాట్ జాగ్రత్తగా వినండి ఈ టాపిక్ కొంచెం డిఫరెంట్ ఓకే మనం ఇంతకు ముందు ఇంప్యూరిటీ మెజర్ ఫైండ్ అవుట్ చేయాలని చెప్పాం స్టాప్ రైటింగ్ లిజన్ టు మీ అక్కడ ఏం చెప్పామంటే మనం డెసిషన్ ట్రీ డ్రా చేసేటప్పుడు ఏవైనా స్మాల్ చేంజెస్ సపోజ్ ద డెసిషన్ ట్రీ పెద్దగా ఉందనుకోండి అందులో ఏదైనా చిన్న చేంజెస్ చేస్తే మళ్ళీ రీకరెక్షన్ చేసి మళ్ళీ డెసిషన్ ట్రీ డ్రా చేసి అందులో మిస్ క్లాసిఫికేషన్ అవుతుందా లేదా అనేది ఫైండ్ అవుట్ చేయడం కష్టం అని చెప్పాం కదా మనం జెండర్ ఇన్పుట్ ఏజ్ జెండర్ యూజ్ చేసి ఇన్పుట్ యూజ్ చేసి డెసిషన్ ట్రీ డ్రా చేస్తాం అది చిన్నది కాబట్టి ఓన్లీ ద నెంబర్ ఆఫ్ ఇమేజెస్ ఆర్ వెరీ స్మాల్ ఓన్లీ 5 or 6 ఇమేజెస్ ఆర్ దేర్ we have drawn the decision tree easily మనం ఈజీగా డెసిషన్ ట్రీ డ్రా చేస్తాం ఒకవేళ సపోజ్ ద నెంబర్ ఆఫ్ ఇమేజెస్ ఆర్ మోర్ I need to draw the decision tree based on all these images which are available in the class. I need to draw the decision tree. Is it difficult for me? Is it difficult for me? Yes, because I don't know who you are. ఇప్పటికీ నాకు తెలియదు బట్ ఐ నో దట్ యూ బిలాంగ్ టు AICSE ML బ్రాంచ్ బట్ ఐ డోంట్ నో విచ్ పర్సన్ బిలాంగ్స్ టు విచ్ బ్రాంచ్ ఇస్ ఇట్ రైట్ decision tree is it workable of index is it right so here for such cases we use bias variance to identify the misclassification and to identify the variance of overfitting and underfitting what is overfitting So here in bias variance, we are going to learn two new words. One is overfitting, one is underfitting. So this overfitting and underfitting will be based on the trained data set only. The difference is in overfitting, we are going to get the misclassification. We are going to get the errors for the testing data. Whereas in underfitting, we are going to get the errors both at training level as well as the testing level. Okay? మీకు ముందు చూపించిన ఎగ్జాంపుల్ కానీ ప్రోగ్రామ్ గుర్తుంటే యూ కెన్ ఈజీలీ ఐడెంటిఫై దట్ గ్రాఫ్స్. By seeing the graphs, you can easily identify how the errors will come. ఆఫ్టర్నూన్ క్లాస్ ఒకసారి గుర్తు చేయండి, మీకు ఆ గ్రాఫ్ చూపిస్తాను. Finish writing this. What is bias? What is bias? Some students are eager to tell the answer. Bias ante entandi? Bias ante enti? ఇక్కడ ఉంది కదా, ఎర్రర్సే. బయాస్ అన్న ఎర్రర్సే, వేరియన్స్ అక్కడ ఉన్నది చెప్పండి. Here, bias and variance, we are going to identify both errors. The first one is due to assumptions, whatever the assumptions we do. The second variance error is due to the small changes we do for the data set, for our decision tree. Okay, next slide. Mundu slide better. So here, normally, every time decision trees have low bias and high variance. What is low bias? See, the errors due to assumptions will be less when compared to the errors we find due to small changes we do in the data set. Okay, next. This is a graph. This is a graph for bias and variance regarding the underfitting and overfitting. Draw this graph. Okay, here we tell that this red line represents the error we find on the trained data set, whereas the green line represents the error we find on test data set. Okay, మీకు ఇక్కడ చూపిస్తాను గ్రాఫ్. రాసిన డ్రా చేయండి, మీకు రియల్ ఇంప్లిమెంటేషన్ ఎలా ఉంటుందో చూపిస్తాను. ఎందుకు నవ్వు వస్తుంది? ఎందుకు నవ్వుతున్నారు? మరి ఎందుకు అట్లా నాకు మీ ఫేస్ లో నవ్వుతున్నట్టు అనిపిస్తుంది? ఫేస్ వాల్యూ అంతనా? నాకు క్లాస్ చెప్పేటప్పుడు నాకు 2-3 ఫోటోస్ తీసి ఇవ్వండి. క్లాస్ చెప్పేటప్పుడు నాకు 2-3 ఫోటో నాకు ఇందులో ఫోటో క్లిక్ చేసి ఇవ్వండి క్లాస్ చెప్పేటప్పుడు. అయిపోయిందా? అయిపోయిందా? ఇక్కడ మీరు ఏం ఐడియల్ రేంజ్ రాసారా? Finish? See here. మీకు నేను ఏం చెప్పాను? అండర్ ఫిట్టింగ్ లో ఎర్రర్ విల్ బి అక్కర్డ్. ఎర్రర్ బోత్ ట్రైన్డ్ డాటా సెట్ దగ్గర, టెస్టింగ్ డాటా సెట్, at both the times under fitting will occur. But whereas coming to the overfitting, the error will occur at only the testing sample. Here we observe, this is the prediction of the error. You know about the graph from 0 to n. This is the prediction of the error, and this is the prediction of the error on the training data set. Here we observe here, whereas coming to the underfitting, error will be error is high for both training data set as well as the testing data set. Is it right? Because the green line shows test data, the red line shows training data. Here the error is more for underfitting for both test data as well as the training data. అవునా కదా? అవునా కదా? మీ గ్రాఫ్స్ తెలీదా? గ్రాఫ్ లో ఇది హై వాల్యూ కదా, 0 to n వాల్యూ. ఓకే, హియర్ ఇక్కడ రెడ్ లైన్ అనేది ఎర్రర్ ట్రైనింగ్ డాటా, గ్రీన్ లైన్ అనేది టెస్ట్ డాటా. అదేనా? ఎస్, ట్రైనింగ్ డాటా, టెస్ట్ డాటా. ఫర్ బోత్ ట్రైనింగ్ డాటాకి టెస్ట్ డాటాకి ఎర్రర్ అనేది ఎక్కువ ఉంది ఇక్కడ. ఓకే, దిస్ we called as underfitting, high bias, underfitting. Whereas coming to the overfitting, for overfitting, error on training data will be less. Okay, compared to the error on testing data. Okay, this graph shows what is underfitting, what is overfitting. In underfitting, both underfitting and overfitting are the errors we find, are the errors we are going to identify. Underfitting, overfitting రెండు ఎర్రర్స్ ఫైండ్ అవుట్ చేస్తాం మనం. దేని మీద? ట్రైన్డ్ డాటా సెట్, టెస్టింగ్ డాటా సెట్. Both two are important for us. So if we get errors for both testing and training at high levels, then we call it as underfitting, high bias. Okay, if we get error more on test data when compared to the training data. Training data error less ఉంటుంది, test data error ఎక్కువ ఉంటుంది. దాన్ని మనం ఓవర్ ఫిట్టింగ్ అంటాం. హై వేరియన్స్, హై వేరియన్స్. ఓకే, సో మీకు డెసిషన్ ట్రీస్ ముందు గ్రాఫ్ పెట్టండి. సో నెక్స్ట్, decision trees tend to have low bias, high variance. Okay, low bias, high variance, combination of both underfitting, overfitting. We can't tell that at which point we are going to get underfitting and overfitting, because decision tree we draw, if at all they didn't give any numerical data or categorical data, based on only our assumptions. ఏముంది అక్కడ? స్టాండ్ అప్. నేను ఏ టాపిక్ చెప్తున్నాను ఇప్పుడు? వింటున్నావు కదా, కూర్చో. సో ఇన్ డెసిషన్ ట్రీస్, ఇఫ్ ఎట్ ఆల్ దే ఆర్ నాట్ గివింగ్, వాళ్ళు కేటగిరల్ డేటా, న్యూమరిక్ డేటా ఏది ఇవ్వకుండా జస్ట్ మనకు ట్రైనింగ్ డాటా సెట్ ఇస్తే, బేస్డ్ ఆన్ అవర్ ఓన్ అజంప్షన్స్, మన ఊహాగానాలను బట్టి వీఆర్ గోయింగ్ టు డ్రా ద డెసిషన్ ట్రీ. ఓకే, ఎట్ సమ్ పాయింట్ we may get the misclassification, just I did in the image కదా, నేను తప్పు చేశాను కదా, మిస్టేక్ ఉంది నా ఇమేజ్ లో. సో హియర్ డెసిషన్ ట్రీస్ నార్మల్లీ హ్యాస్ low bias, high variance. See the graph, low bias. Here we are having high bias, high bias. Actually it has low bias, high variance. Low bias, high variance means whenever a decision tree is perfect when the training data set is correct. Okay, but the error may occur at the testing data set. By this, what you understood is, whenever we draw the decision tree, we are not going to find the error at the training data set. We will find the misclassification only on the testing data set. Only at some point of time we will get training data set. Before only we are going to find the validation testing accuracy. Based on that we are going to reuse the different algorithm. So this is the graph for underfitting and overfitting, for to understand the low bias and high variance. Decision trees uses low bias, high variance. Okay, this is the high variance. Next, నాకు ల్యాప్టాప్ ఇవ్వండి, నేను మీకు గ్రాఫ్ చూపిస్తాను. ముందు గ్రాఫ్ పెట్టండి, ముందు ఏం లేదు. Don't waste time. I am going to check the notes at 12 o'clock. So look at the board. Stop writing. Previous slide we have discussed about the training data set and testing data set, where we are going to we are going to know about underfitting and overfitting. What is underfitting? What is underfitting? Underfitting. Errors is more both for training as well as the testing data set. Whereas for overfitting, errors will be more for testing data set when compared to the training data set. So this is the program, basic program, which I have done for my data set, which I have loaded, which I have developed a model, trained a model for executing my research. So here I am having some data set on my agriculture area, which I am doing on agriculture. So I have some list of classes of images. I have trained a model. Here you can, are you able to see? Blue color highlight chesana. It shows how many images I have loaded into my model. Okay, how many images I have loaded into my model. So now my task is to load this all data set to train a model, to train ML model. Later on, I have to use this model for testing my sample data set, for testing my own data set. ఇప్పుడు ఉన్న data set ని నేను నా ML model కి train చేయాలి. Machine learning అంటేనే అది కదా. What is machine learning? We have to train a model. Later on, for AI, we are going to use that model to mimic same as the human. Now I am training a model with the available data set. నా దగ్గర ఏదైతే data set ఉంటుందో నేను వాటితో నేను ఒక మోడల్ ని ట్రైన్ చేస్తున్నాను. Later on, for future, for any time, I can use that model. Okay. Now, do you have told one pre-trained model in the first class? What is that pre-trained model? Mobile V2Net model. Here you can see I am trying to get the graph. I am trying to get the graph between the training data set, means whatever the data set I want to develop, whatever the model I want to develop, I need a graph comparison. I need performance metrics. మీకు performance measures అని చదివాం మనం నిన్న క్లాస్ లో చదివామా So I need the performance measure between the data set which I want to train. ఏదైతే data set ఉందో ML model, machine learning model train చేయాలనుకుంటున్నానో దానికి I want the accuracy. ఎవరైనా పడుకుంటే మాత్రం నేను ప్రోగ్రామ్ లో డిఫరెంట్ చేంజెస్ చేసి గ్రాఫ్ జనరేట్ చేస్తాను, ఆ గ్రాఫ్ ఎక్స్ప్లెయిన్ చేయాలి. I can do the changes. That thing you also know. నేను చేంజెస్ చేస్తాను, నేను ఎట్లయినా ఆ జనరేట్ అయిన గ్రాఫ్ మీరు ఎక్స్ప్లెయిన్ చేయాలి వచ్చి బోర్డు పైన. జాగ్రత్తగా వినండి. హియర్ I want the graph between the training and the accuracy validation. Okay, now we will see the two graphs. Here this graph is there. ఈ గ్రాఫ్ ఉంది కదా, ఈ గ్రాఫ్ లో సేమ్ కంపేర్ టు ద అండర్ ఫిట్టింగ్ ఓవర్ ఫిట్టింగ్ గ్రాఫ్. ఓకే, హియర్ ఇన్ దిస్ లాస్ట్ whatever the red and blue line you are seeing, it becomes for the overfitting. Is it right? It tends for the overfitting, whereas the error you see there, that becomes for the underfitting. Okay, enduku is it necessary for generation of the graph? Is it necessary for comparison of the trained data set? మనం ఏదైతే డాటా సెట్ ని ట్రైన్ చేస్తాం కదా, ఎంఎల్ మోడల్ ట్రైన్ చేస్తాం కదా, అది కంపారిజన్ చేయాలా, మనం చేయాలా వద్దా? whether it may be a decision tree or any other model or any other thing, is it necessary for getting the accuracy level? Yes. Yes or no? So for that model I have done the training and validation accuracy. After that, this is the model name which I have given for my data set. మేడం కెరాసా ఎందుకు ఇచ్చారంటే మెషిన్ లెర్నింగ్ మోడల్ కి మనం ఏ మోడల్ అని ట్రైన్ చేసుకోండి. యూ కెన్ కీప్ యువర్ ఓన్ నేమ్ ఫర్ దట్ మోడల్, బట్ ఎక్స్టెన్షన్ ఈస్ డాట్ కెరాస్. Here you can see the graph for loss. The first graph is for accuracy and the second graph is for loss. Okay. ఇది ఇన్ డీటెయిల్ గా ప్రోగ్రామ్ ఎక్స్ప్లెనేషన్ కావాలంటే నాకు ఒక 1 వీక్ టైం ఇవ్వాలి. ఓకే, అప్పుడు మిమ్మల్ని ప్రోగ్రామ్ లాగా నేను ప్రోగ్రామ్ రాయడానికి మిమ్మల్ని ట్రైన్ చేస్తాను. టైం తక్కువ ఉంది కదా, అందుకే ప్రోగ్రామ్ ఎక్స్ప్లెయిన్ చేయట్లేదు. Keep heading. Keep heading random forest. Random forest for classification and regression. ఏం చేస్తున్నారు మీరు? So listen here, look at the board. Finish writing. Finish writing. Now after this I am going to check the notes. Okay. Otherwise you need PDFs. You need code. You need code. You need PDF. So I also need some requirement. Now we are going to enter into random forest for supervised learning. Previous overfitting, underfitting, అక్కడ నుండి తీయరా బాబు, ఇక్కడ నుండి అండి. Overfitting graph పెట్టండి. In this, we are telling that for overfitting, the error will be on test data. Okay, if at all this test data, if we reduce the error on the test data, then the decision tree which is made on this reduction of no error while testing and training data, it is very suitable and it is very correct. Is it right? ఇప్పుడు మనం decision tree కి చేంజ్ అయ్యింది స్లైడ్, random forest కి వెళ్ళండి. ఇప్పుడు మనం decision tree కి ఏమని చెప్తున్నాం? The error will be data set, test data set ki error untundi overfitting lo, training data set ki error undadu ani cheptunnam. Okay, so if we manam aa test data error kuda taggincham anukondi, then the misclassification edaithe tappu jarugutundo decision tree chesetappudu adi reduce cheyocha, manam cheyocha, reduce cheyocha, cheyodda adi cheyadaniki now we will use the random forest algorithms. Random forest for classification and regression. Okay, here in random forest, this random forest algorithm is going to divide the tree into multiple splits. మనం ఏదైతే మల్టిపుల్ స్ప్లిట్స్ చేసాం కదా ఇంతకు ముందు ఒక గ్రాఫ్ కి, మల్టిపుల్ స్ప్లిట్స్ చేసామా, 1 2 3 4 వరకు మల్టిపుల్ స్ప్లిట్స్ చేసాం కదా. మల్టిపుల్ స్ప్లిట్స్ చేసిన తర్వాత మనం ఒక్కొక్క స్ప్లిట్ తీసుకొని దాన్ని వెరిఫై చేస్తూ పోతే we can reduce maximum errors. Is it right? Is it right? We can reduce maximum errors and at last we can combine all the data at one and we can show the final result. Is it possible? Split chesama cheyaleda graph lo? Idra baba graph. See here, look at this graph. Look at this graph. ఇప్పుడు ఈ గ్రాఫ్ లో మీరు డాటా పాయింట్స్ ని ఐడెంటిఫై, దీనికి వాల్యూస్ లేవు కాబట్టి if I tell to identify one data point, is it easy for you to search that data point in this graph? Is it easy for you? మీకు ఈజీ ఉండదు. In this fourth graph there are number of splits చాలా ఉన్నాయి. It is easy for you to find out the data point. Yes, ఈ స్ప్లిట్ లో మీరు డాటా పాయింట్ ఫైండ్ అవుట్ చేసి నెంబర్ ఆఫ్ స్ప్లిట్స్ అయిన తర్వాత ఇందులో డాటా పాయింట్ ఫైండ్ అవుట్ చేసి you can combine all the answers. Now you can easily tell that the data point is here. Is it right? So in the random forest, in this random forest we use to reduce the errors in overfitting, to reduce the errors in overfitting by doing number of splits and combining all the answers at last. That is random forest for classification and regression. At last, we will combine all the results and implement by reducing the overfitting. Okay, error on testing data, more error on testing data. Okay, next slide. Random forest for classification. So in classification task, the random forest we use most common class among all decision trees. Write down this point. Now we will see one program regarding the random forest, how it is implemented in practical way. Look at the program, look at the board. The random forest we see, the random forest classification we are using to reduce the accuracy, to reduce overfitting. Okay, you know what is an overfitting? We are going to reduce the error which is going to occur on training data set or testing data set. Training data set or testing data set. In overfitting, error is more on testing or training. In overfitting, error is more on testing and training. Testing data set. So our task is to reduce the error on testing data set. That is, we have to reduce the overfitting. This way, for reducing this, we are taking the help of random forest classification. Okay. Now we will see here. Here I am splitting the data set available with me. Okay. And also I am splitting the data set into training as well as the testing. If suppose I am splitting the data set of a data set of different as different subsets. Similarly, I am splitting the training data set into multiple subsets. Meeku gurtunda information gain formula? Information gain, impurity measures lo information gain undi. Information gain, we are finding the difference between the parent as well as the subsets of that parent. We are calculating the entropy value. Okay. So in such cases, leave it that here we are splitting the data set into different points depending upon our decision. See here how the classification is. Normally the estimated classification is 100. We are doing here is 42. It can be changed. So here we have to predict and evaluate the testing on training and testing data set. Here we are reducing the overfitting. So by using the random forest classification, whatever the training and testing data set we are using for reducing the overfitting, here we have got that random classification accuracy is 1.0. Okay, we have reduced the overfitting, error of overfitting to 1%. 1% ante the error is very less. We can use for further projects or anything. Okay. So write down random forest for regression. After this slide, I will ask you some questions regarding the programs I have shown you. Program lo nenu mottam explain cheyakunna gaani important points koni explain chesanu. Okay. Now I will ask the questions from you. The next slide is that only. నేను మళ్ళీ అక్కడ క్యాంటీన్లోనే కూర్చున్నాను బయటకు వెళ్దామంటే ఫినిష్ రైటింగ్. నెక్స్ట్ పెట్టే స్లైడ్ లో మీకు కొన్ని పారామీటర్స్ ఇస్తాను. ఆ పారామీటర్స్ ని కంపల్సరీ నోట్ డౌన్ చేసుకోండి. దాన్ని బట్టిఫై చేయండి. ఎలా అంటే ఒక పారామీటర్ గురించి చెప్తే యూ షుడ్ బి ఏబుల్ టు ఆన్సర్ ఫర్ దట్ పారామీటర్ ఫర్ ఎవర్. ఓకే, ఫస్ట్ కాపీ డౌన్ ఫాస్ట్. Finish? The disadvantages we learned from decision tree is, if suppose it is a large data sets are there, if any error is or any changes has been done to that decision tree, it is difficult for us to find the misclassification. Okay, whereas when we use this random forest, it can be used for non-linear relationship also. ఓకే ఎగ్జాంపుల్ మనకి ఇమేజెస్ 5 ఇమేజెస్ ఇచ్చారు కదా మేల్ ఫీమేల్ ఇమేజెస్ అవి చిన్న ఇమేజెస్ కాబట్టి ఐ కెన్ ఐడెంటిఫై బై యూజింగ్ ద ఏజ్ if same these images has given to me, it is very difficult for me to identify to classify you people. So in such cases, in non-linear relationship and for the large data set, to avoid the misclassification, we can use this random forest very good. Okay, because in random forest it is doing multiple splits, division of multiple subtrees. Now we will see next parameter. Next ppt pattern. Do you observe this max depth? Have you observed the max depth? Where I have used this max depth? ప్రోగ్రామ్ చేసేటప్పుడు ప్రతి ప్రోగ్రామ్ లో మీకు మ్యాక్స్ డెప్త్ అని దానికి చేంజెస్ చేసి డివిజన్ చూపించాను మీకు. ఎందుకు యూజ్ చేసాం నీ మ్యాక్స్ డెప్త్? మ్యాక్స్ డెప్త్ ఎందుకు యూజ్ చేసాం? అక్కడ ఉన్న చెప్పొద్దండి, అలా చదివితే మెషిన్ లెర్నింగ్ సబ్జెక్ట్ రాదు. లైన్ టు లైన్ చదివితే మెషిన్ లెర్నింగ్ సబ్జెక్ట్ రాదు. మీరు అబ్జర్వ్ చేసి ఉండొచ్చు, నా స్లైడ్స్ లో ఎక్కువ మ్యాటర్ ఉండట్లేదు, బొమ్మలే ఎక్కువ ఉంటాయి, అట్లానే చదవాలి. మెషిన్ లెర్నింగ్ సబ్జెక్ట్ రాదు లేకపోతే. మీకు మ్యాక్స్ డెప్త్ ప్రోగ్రామ్ లో చూపించాను. మ్యాక్స్ డెప్త్ ఎందుకు యూజ్ చేశారు? ఎందుకు యూజ్ చేసాం మ్యాక్స్ డెప్త్? మిమ్మల్ని మ్యాక్స్ డెప్త్ ఎందుకు యూజ్ చేసాం? యూజ్ చేశానా ప్రోగ్రామ్ లో? ఎందుకు యూజ్ చేశాను? ఎందుకు యూజ్ చేశాను మ్యాక్స్ డెప్త్? వినట్లేదా? ఎందుకు యూజ్ చేశాను మ్యాక్స్ డెప్త్ ప్రోగ్రామ్ లో? నెంబర్ ఆఫ్ ట్రీస్ కాదండి, దాన్ని ట్రీ అనం. నెంబర్ ఆఫ్ కూర్చో. See, in the program, we have used number of times this max depth, and also these are the different parameters which should used for our random forest. Okay, why we are using these parameters? Max, minimum sample split, minimum sample sleeve is this minimum sample split is, we are telling that the random forest is going to divide multiple, use multiple decision trees, and at last it is going to combine the answer. Okay, program open cheyandi. Look at the board. Look at the board. In the previous slide, we have seen the different important parameters for a decision tree. Okay. The previous slide is the important parameters for the random forest. For each and every program of a decision tree, whether you are using for overfitting or underfitting or random forest linear regression or random forest regression or anything, the main parameter will be the max depth compared to other parameters. If you are using for a linear regression or for random forest or for decision tree, max depth is an important one, because in this max depth only we are telling the program, we are telling the program how many levels should be there. except for the root node. Other than the root node, till how many levels you want the decision tree? You want number of children. If you keep here 5 or 6 or anything, చూద్దాం 6 వస్తుందేమో. Is it coming? Now we will see for one whether it comes or not. See, in the program I have given max depth equal to 1. It means that I need only one level of children. Here random, there is no need for the random forest. If the number of levels are more, if we implement with random forest regression, then it will be used for reducing the overfitting. Okay, like this, the parameters are very important for you for implementing the decision trees. Whatever the model you use for implementing the decision trees. Write down these parameters. Completed? Look at the board. Here, we will use the different parameters, the main parameters for executing our program. The first one is number of estimators. మీకు ఇంతకు ముందు ప్రోగ్రామ్ లో ర్యాండమ్ ఫారెస్ట్ లో I have taken the number of estimators as 100. బట్ ఆర్డీ అనే ర్యాండమ్ ఆర్డీ ఏమో నేను 42 శాంపిల్స్ తీసుకున్నాను. మీరు అబ్జర్వ్ చేశారో లేదో, ఆ నెంబర్ ఆఫ్ ఎస్టిమేటర్స్ విల్ బి 100. ఒకవేళ మీరు రాయకపోయినా కానీ బై డిఫాల్ట్ ద నెంబర్ ఆఫ్ డెసిషన్ ట్రీస్ ఇట్ విల్ టేక్ యాజ్ 100 ఓన్లీ. ఓకే, యువర్ రిక్వైర్మెంట్ యూ హ్యావ్ టు మెన్షన్ ఇన్ దట్. నెక్స్ట్, మ్యాక్స్ డెప్త్, number maximum depth for each tree. How many levels of children you need? You have to mention in that max depth equal to the numerical number. The next one is minimum sample splits. How many splits you want? In the graph, whatever the graph of different data points we have seen, in that graph they didn't mention how many splits they want. We ourselves have decided, assumed, and we have given the 4 number of splits. But if how many splits you want, in that I have given 42 splits I want in the previous example. Here you have to mention how many splits required for that code. Minimum samples of leaf, minimum number of samples required for leaf node. Okay, if you decide this number of samples to split, the number of leaf nodes generate, whatever the leaf nodes to be generated will be automatically, you can assume kada. ఎన్ని స్ప్లిట్స్ ఉంటాయి, ఎన్ని నెంబర్ ఆఫ్ చిల్డ్రన్ కావాలనుకుంటే లాస్ట్ లో ఉన్న లీఫ్ నోట్స్ అన్ని లీఫ్ నోట్సే కదా, లాస్ట్ లో ఉన్న చైల్డ్ నోట్స్ అన్ని. ద నెక్స్ట్ వన్ ఇస్ మాక్సిమం ఫీచర్స్. ఓకే, హియర్ నెంబర్ ఆఫ్ ఫీచర్స్ టు బి కన్సిడర్డ్ ఎట్ ఈచ్ స్ప్లిట్. ఓకే, ఆ జెండర్ గ్రాఫ్ పెట్టండి. పైకి వెళ్ళండి. ఇంకా 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 tell me, here this is an example. Okay, what are the maximum features we want here? What are the maximum features we want here to classify this data? What are the maximum features we are considering here? Age, gender, occupation. Here, this is the initial stage 0,0, correct? This is the initial. Let us talk in a programming language. This is the initial stage 0,0. Avuna? This is the initial stage where the data set is there at the location 0,0. Is it right? Okay. Here we are considering the maximum features input as age, gender, and occupation. Okay. Now tell me, this is the location 1,1. This is the location 1,1. Here we are considering the feature age, only one. Okay, one feature we are considering here. Okay, coming to here, what is the feature we are considering here? Gender. What is the feature for later on split of this year we can consider? Gender. Gender ఏ కదా, ఇంకా మనం డెప్త్ కావాలంటే మనం ఇక్కడ ఇంకా ఏం ఫీచర్ యూజ్ చేయాలి? Gender. Okay, so for random forest, the number of features, the parameter and the max features. Here we are going to tell how many features we need for split of that particular split. Not first split, second split. The point where we want to do the splitting of the data, at that point, how many features you need. This is a sample data. This is a small example you have considered. For the large data set we are talking. Here at that particular split, how many features you needed, you should give at this max underscore features. Okay, these are the most important parameters for you people to implement the decision trees in machine learning. Okay, the next slide. Keep heading bias classifier, base classifier. అయిపోయింది. Finish? Stop talking. So here we are using the Bayes rule for to predict the probability of a class. Till now we have learned for impurity measures, we are going to calculate the probability for each class. Here, based on that also, it is going to predict the labeled class, predict the probability of class table. Okay, this depends upon the given features. Whatever the features we are going to consider for each split. For each split, based on that, this Bayes classifier Bayes theorem is used to predict the probability of a class. So these are the important key terms. The first one is the prior probability, where we are going to find out the probability before seeing the data. Okay, before actual classification. Likelihood, the probability of the data in the given class. This is before, this is when we take all the features available for that given class. Next, posterior probability, the probability of a class given the data what we want to compute. In the given example, they have given the different attributes input as age, gender and occupation. From the given attributes, here we are taking the posterior features. What features we need? Okay, they have given input as age, gender, occupation. He didn't told that all the features you have to take for each split, but we are taking whatever the features we need for that particular split. Okay, last one is this is the evidence which we are going to calculate that features suits best for that split, particular split. We will see the formula here. This is the Bayes rule. This is the Bayes rule where we are going to calculate the probability of different class on the given data. The first one is y by x. This y by x is we are going to calculate the probability of y based on x. Here we are going to calculate the likelihood of x based on y. This p of y is the prior probability. This p of x is the evidence we are going to calculate. Write down this formula. Finish? నేను చెక్ చేసేటప్పుడు ఒక Where is unit 1? Stand up. Where is unit 1? After writing the table, look at the base theorem. Look at the base theorem, base formula. Look at the base solution for this example. చూడండి base theorem. Try to solve. Try to solve. Take contents free as x, class as y. Try to solve. After lunch 4 slides ఉంది క్లాస్ ఎంతైంది టైం ఇప్పుడు అవ్వదు అన్నీ చెప్పాలంటే ఒక హాఫ్ అన్ అవర్ పడుతుంది Try to solve this problem using base theorem. Where is unit 1 and unit 2?